Good morning. My name is Sean Walsh. I'm Director of Federal Business Development with Noresco. My background, I'm a retired Army colonel, and I got interested in energy as a battalion commander on the battlefield in Iraq. Having soldiers move fuel every day, fuel plus generators equals energy. So the problem set I took with me the rest of my military career and then work as a civilian at the Pentagon is how do we get better, how do we become more efficient, how do we reduce consumption of fuel, which really saves soldiers' lives on the battlefield. So I'm really privileged today to be introducing this panel, very impressive with their resumes. I'm going to keep it very short on who they are, what they do, but I think they all need some sort of introduction. So Dr. Ivester talked to us about his role at FEMP, policy actions, overseeing energy efficiency, renewable energy, and technology, everything that you heard first thing this morning. He did receive a doctorate in engineering and a Bachelor of Science in Mechanical Engineering and a Master of Science in Manufacturing Engineering from University of Massachusetts at Amherst. Being from New Hampshire, I like New Englanders. We also have another one on the panel we'll introduce in a minute. So sitting next to Dr. Ivester is Jason Schneider. He is a senior program manager at TVA and leads energy rights solutions for business and industry innovation team. He tracks market trends in customers, technology, trade allies, and program delivery, and works toward implementation of best practices into strategic planning. He's also focused on the rollout of digital consumer engagement platform. He's a licensed mechanical engineer, lead certified professional, and a certified energy manager. He earned a BS Mechanical Engineering, University of Tennessee, and a Master's in Engineering Management from Christian Brothers University. Sitting next to Jason is Stacy Cantrell, Vice President of Engineering at Huntsville Utilities, and her projects include Huntsville Utilities Advanced Metering Infrastructure System and Fiber Network Expansion for Internal Communications and for Lease. She lives in Huntsville and attended North Carolina State University. Then we have Dr. Bob Strait, Resource Efficiency Manager with Sane Engineering Associates, where he's assigned to Headquarters Army Materiel Command. Dr. Strait is currently involved in developing the next generation of energy productivity processes and systems, where he's working with professionals from industry and national laboratories to implement processes and technologies to integrate energy efficiency concepts into overall mission and business planning. He is an active member of Department of Homeland Security's Industrial Control Systems Cyber Emergency Response Team, that's a mouthful, and Department of Homeland Security's HISN Users Working Group. His education includes Excelsior in New York, where he studied math, science, and technology, and he is currently working PhD work at Arkansas State University. Did I get that right? All right. Next, another impressive resume. John Mara has over 35 years experience in industrial gas turbine, aero engine, and rocket engine design, development, and test with Siemens and other manufacturers. He's managed development programs, led the development of design tools, pioneered new business models, and executed designs, including on the Space Shuttle main engine alternate turbopumps. He's been awarded over 30 patents and has authored numerous technical papers, magazine, and journal articles. He's a graduate of the University of South Florida. And last panelist and last to speak will be Mr. Kareem Manji, a general engineer assigned to IMCOM's Sustainment Directorate at Redstone Arsenal. He has extensive background in HVAC design, nuclear power plant design, construction, facility operation maintenance, licensing, quality assurance, and energy management. He served as energy manager and environmental program manager with the Air Force and with Huntsville Corps of Engineers, Huntsville National Center. He worked in the Energy Division Commercial Utility Program. Currently, again, with IMCOM supporting energy and environmental programs for 17 installations. So Kareem earned a BS in mechanical engineering at a school that really means a lot in the state of Alabama, especially in the last 4 years. Anyone know what school that is? Clemson. Clemson University. So if you're a football fan, you know what I'm talking about. He also has an MS in environmental management from Stanford University. So very impressive panelists. And before we get started, a couple questions were asked earlier this morning about how many scientists in the room, engineers in the room, those of you from Huntsville who are buying lunch today. But just to get a little bit more flavor, federal sector, how many in the audience? All right, state government, Alabama, anybody? All right, great. Academics, industry. All right, super. So we have a well-rounded audience, and we will turn it over to the panelists. And what I'll do is keep time here up front, about 10 minutes each, and then we're going to open it up to Q&A. Dr. Iverson.
All right, thank you. So I'm just going to give a quick overview of the FEMP program and a couple of slides on the Advanced Manufacturing Office. Just looking here at the cumulative cost savings and the cumulative investment. So the blue line is the cumulative investment. So the federal government has put about $20 billion cumulatively into energy conservation and energy savings, and we're seeing a projection of $49 billion of return by 2030. That translates into 174,000 jobs, and we see about between 9 and 15 billion of cost-effective potential still out there for additional investment. And so we talk about FEMP. It's a little small to see, but it's 5 segments of the wheel, and I'm going to work through it counterclockwise. We have a significant role across the federal government for strategic programming and integration planning for federal energy efficiency, where we work with our partner agencies on their strategic planning. Really a big focus for us right now is on resilience. And we also have a lot of work around legislative and executive order guidance. So helping the federal sector understand what the law means, what the executive order means, what's the intent behind it, how do we successfully carry out directives to meet those requirements. We have we serve in a leadership on behalf of the federal government and engaging with the federal government. So we have a variety of events on the left. The Energy Exchange, if you haven't heard of it, it's an annual event that FEMP runs. And the next one will be in August in Denver. So the Save the Date announcement is out. So August 19th, it kicks off out in Denver. So I would encourage you to mark that on your calendar and think about getting out there. It's a great opportunity for folks across the federal government to hear from each other and see what they're doing in energy savings. And we also have some work in this area around workforce development. So we do a significant amount of training for the federal government, and Energy Exchange is a great place to go and get some of that training. We also have a veterans interns program that we're very excited about, that we've just made announcements on the current round of interns, and would encourage you to think about hosting an intern in one of your agencies. Modernizing and managing infrastructure. So there's, this goes back to that $2 billion in investment with an additional $9 to $16 billion to go. And there's two major flavors of investments. One is direct appropriated dollars for new projects, and the other is through energy savings performance contracts, which I assume most of you are familiar with. We at DOE, we manage and operate an IDIQ contract that enables agencies to tap into ESPC authorities and implement energy improvements through that. And I want to also put in a plug for our project quality assurance activities, particularly around e-project builder. So wherever you are in the federal government, any energy project improvements that you have in the works, I would encourage you and invite you to use the e-project builder tool to track your progress and help get credit for the changes that you're bringing into your agency. Resilience and reliability. So we've seen just a massive growth in interest across the federal government in resilience, and how do we account for the importance of resiliency. And the short version of it, or my perspective, is energy resilience is very different in a professional environment, and needs to be treated very differently from how the power company treats me as a resident, where if I lose power, they give me a small refund on my energy bill, and I don't get charged for the energy that I didn't use. And that does not value appropriately me as a customer. I've voiced this to my utility company that will remain nameless, but isn't hard for you to figure out because I'm from DC. But the way I think of it is, what's the value of an operating facility? And so I'll just make up some numbers here. But let's suppose that Redstone Arsenal costs the Army $365 million to operate on an annual basis, and then Redstone Arsenal is not operational for a day. The Army just spent $1 million, and it didn't get $1 million of value out of the money that it just spent. So it just lost $1 million. So for every day that a $365 million operation is down, it's lost $1 million. That's the value of resiliency, is if you're stopping yourself from going down, that should be valued at $1 million a day. And that, I think, is the appropriate way. And it's a three-tiered structure. The first tier is your actual energy costs. Your second is your overall cost. Your third tier, it's actually more than that, because it's a disruption, and valuable work being disrupted has a timeliness to it. And so it actually should be more than $1 million a day, but $1 million a day is easier to defend than kind of that longer term, what did you lose because a particular facility was down for a day. And next slide, please. And then lastly, facility and fleet optimization. A big part of this is Executive Order 13834, which puts out a bunch of guidance for use of water and buildings and metering and fleets, and we provide technical assistance into federal agencies as to how they implement these guidelines. And it should be in here, but I don't see it. One of the things that we're working on from a facility optimization standpoint is encouraging adoption of the ISO 50001 standard. And one of the tools that we've introduced is 50001 Ready, which is a self-administered process for assessing internally how ready for 50,001 you are, and we help adopters of that tool progress towards 50,001 ready status, which is a self-certification, and then that's a stepping stone towards ISO 50,001. And there's going to be a session at 2:15 today, so if you're interested in learning more about 50,001 ready, Jay and Niall will be happy to answer questions, and I would encourage you to go to the 2:15 session. So I talked about the High Performance Computing for Manufacturing program a little bit earlier, so this is just some logos of some of the companies that have used it. There's been about $18 million in funding across 5 rounds of awards, and we've seen some really exciting results come out of it. I'll be happy to share some if there's time and there's a question, but in the interest of keeping things moving, I showed the little picture of the 3D printed Shelby Cobra. The manufacturing demonstration facility is the place where that was made. They're working on a wide variety of 3D printing technologies. It's just a few hours from here, so if you're here in the Huntsville area, I would strongly, strongly, strongly encourage you to go visit Oak Ridge National Lab and see the MDF. It's a magical place where magical things happen. And I think that's, yeah, that's it for me. Thank you. Maybe you'll have better.
Thanks. So I'm Jason Snyder with Tennessee Valley Authority. And Sean, I appreciate your question before we really got this one going about who's in the audience. So hopefully I'm going to share a couple of things for those federal companies and also the industries that are out there in the audience, some ways that you can partner with TVA and your local power company, like Huntsville, to get more things done back when you get back to the office as well. So just a quick overview of what TVA is. You can see the territories that we're providing power to kind of outlined on that map. There's 154 local power companies and 58 direct served customers. If you're one of those federal customers, you might be one of those 58 direct served. We're founded in 1933. We are owned by the U.S. government. We provide electricity for about 9 million people across 7 southeastern states, 16,000 linear miles, 53 power plants, and that number is actually going down a little bit on the number of power plants. If you have been checking the newspapers recently, retiring 2 more of the power plants in the future. Entirely funded by sales of electricity. We're a nonprofit and we receive no taxpayer money. And also control floods, do flood control, really important right now. The guys that control those dams are working around the clock to, it's one of those times where you recognize that if the dams weren't being controlled through the TVA and the Corps of Engineers, where would we be in the valley right now? So this is a time that is extremely important. Some of those things that are the lesser known TVA services are very, very important right now. At TVA, we talk about a 3-pronged mission. We say the 3 E's a lot of times. It's energy, environment, and economic development. We want to deliver affordable, reliable power. We want to care for the region's natural resources, and we want to create sustainable growth for all of our economic areas. And then on the right-hand side, if you've ever seen any of our board meetings, that's something that our CEO might put up, and that's kind of the strategic direction. Maintaining low rates and kind of how those things are kind of balanced together with living within our means and being responsible stewards and meeting reliability expectations with that balanced portfolio that includes lots of different ways that we generate the electricity. So my area in Energy Right Solutions for Business and Industry creates programs where we partner with local power companies to give individual customers, consumers, the opportunity to partner on different ways that you guys can manage energy even better than you already are. But what we're also noticing is that customer preferences are changing. Some of those little symbols up there, handheld devices, the RE100, reducing CO2, these are things that are changed in the past 10 to 20 years that continue to change going forward, and they change the way that we want to talk to customers and the way that your power company has to kind of relate with you. when we talk about some of those demands from the market, the RE100, the stated renewable energy goals, REBA, these are all companies that have come forward and said that sustainability matters to them. And so what we're seeing is an increased call for opportunities to do renewables, increased opportunities for being more efficient, and ways to use energy just smarter. On the Energy Right Solutions team, we kind of have packaged those 3 E's into a different way. We offer incentives toward decreasing that allow us to decrease the incremental cost of each unit of electricity. So for the past 10 years, we have offered energy efficiency incentives. Over the last year, we've started to offer something that's around smart energy technologies. It may be using more electricity than you have in the past and less of something else like diesel. One example might be a mining operation that has forever used dump trucks to take things up and down a hill, can use an electric conveyor. It may be miles long. But what they do is they unlock some of that productivity, Rob, that you talked about earlier. It's not about simply the amount of energy reduced or the electricity reduced. Sometimes you can use more electricity and be more productive. And so at the same time, TVA actually has a little more generation than we have to have most of the year. So adding a little bit more load actually allows us to use those resources to their fullest extent, which lowers the incremental cost of each unit of electricity. So as we sell more, it's a decreasing pressure on the rates. And since we're nonprofit, we're always balancing the cost with what we're able to sell power for. So we sell that to the local power company, and they're able to sell it to you at lower prices when we can manage those rates. And so the other thing we're doing is we're only doing these for particular areas where it's good for the environment too. So one example is, again, those diesel emissions are going away, and now there's no site emissions, and they're being created. All the emissions are actually being created at a plant that has dropped their carbon footprint by 58% and continuing to drop into the future. And so it's moving energy into an area that actually has, in the future, an ability to become renewable, whether that's a year from now or 50 years from now. That diesel is now something that could be, it's connected to a grid that's getting cleaner every day. And so from an economic development standpoint, we're helping the individual industries that receive those incentives, but we're also unlocking potential for the rest of the customers if we can keep those rates low. Incentive program offerings, we call them the Energy Right Solutions for Business, and then a separate program for industry. And you'll see the quick links at the bottom at energyright.com. The ability to go in there, you can see all the things that we have that are standard incentives, where there's $1 per unit of things that are installed, whether that's dollars per ton of certain types of HVAC or dollars per individual piece of equipment. And so we can also provide unbiased, reliable technical assistance and incentives to help identify process energy-wise solutions. So we have local power companies all over the states that we serve, and if you call them, and they'll kind of be the first line of helping you solve problems, and then they can call on different resources within TVA, and we can assist as well. We also have programs specifically for federal companies, the FESP, and throughout the service territory, that's a one-stop entity that serves for audits, design, engineering, construction, financing, with TVA managing all phases of these projects. And the subcontracts actually happen with qualified service professionals that TVA has utilized in the past. And we actually confront the capital costs on those, and they're repaid from energy savings. So that might be an opportunity that you don't know about. I know that I'm going to share several that have projects that are already ongoing on this next slide, but there are opportunities if you're not aware of those as a federal entity. And we just want to help you meet the mission that you have and achieve your energy goals. And so another kind of buzzword there at the bottom that utilizes the Utility Energy Services Contract. And so that's actually something that was created in the Energy Policy Act of 1992. And the section there is also listed, but that's one way that we can look at helping to fund that and basically create a contract on an individual basis. Some of the successes that we have on that area, We've been offering those since 1999, over 30 projects completed. You can see one of the local customers who I believe is sitting on the panel with me today, Redstone Arsenal. Some projects that have been successful there, Fort Campbell, the NSA in the Mid-South there, the IRS, and NAS Meridian. And current projects in development, so we're going back to the same customers sometimes several times, and they have more strategic initiatives that they want to complete. And so we continue to build that relationship over time, and hopefully they'll keep working with us. So we try to do a good job. And then from a renewable standpoint, we have kind of three parts of that renewables process there. There's the in-valley renewables, where we may own or operate some renewables in the valley. There's out-of-valley wind that we have power purchase contracts. And then there's different types of renewable resources. And so you can see each of those as kind of a portion of the overall story there, and also provided a quick link for that and also an email address if you guys have questions that are specifically around the renewables. And so that completes my section, and I guess it's my honor to pass the microphone to our customer, Stacy with Huntsville Utilities.
Thank you, Jason. I'm going to stand up because combination of being 5'1" and sitting on the side of the podium, I can't see 1/3 of the room. So just quickly, again, I'm Stacy Cantrell, and I'm currently the Vice President of Engineering at Huntsville Utilities. I've been there over 23 years, done a lot of different things in my career there. Before that, I worked at Florida Power and Light. Completely different experience to work for a large, cumbersome, almost investor-owned utility, and then come to this municipal utility that's actually what we call local power company, an LPC for TVA. So it's quite a different arrangement and actually quite refreshing. But Huntsville Utilities has been around since 1940, serving customers in the area, providing water, natural gas, and electricity, and more recently, dark fiber services. So, and we consider ourselves partners in this community. We want to be partners with our customers. Some great things are happening in Huntsville, and we just want to be partners and help make that happen. I'm proud that we can offer reliable and safe and low-cost utilities that help attract people into the area, largely impossible through our relationship with TVA and being able to purchase low-cost power. Then the burden's on us to efficiently get that out to all these businesses and keep it reliable, keep it on when everybody needs it. I know a lot of you here are local, and those of you that aren't, if you've driven around any, certainly if you came in from the airport and looked out the window, you know there's a lot going on in Huntsville. Just a few examples of recent examples of our economic development, some of the places that are coming in here. TVA also works with us there. The Chamber of Commerce is initiating a lot of this. But we've brought in some pretty significant businesses, as well the urban development. And I had to show you a picture of the trash panda, our mascot for our baseball team. So, but a lot of really cool things are coming into Huntsville. I've seen a lot happen in the time that I've lived here. But some really neat urban mixed-use developments are going on in downtown Huntsville, the outskirts of Huntsville, and in Madison. So it's really fun to see what all is happening. Now, what do we do to support all this? What happens? Here's a picture of just a load curve. This is pretty typical for any given feeder that might serve several hundred residences. Any of these larger developments that I talked about may actually require 2 or 3 of these feeders to come in and support all of the load. But this is a typical load curve for one day, for 24 hours. And depending on the time of year, that may move around a little bit. It may peak a little more, in the morning or in the afternoon for the summer. This one is for January, so it's a winter curve. But they all have this similar looking curve, and there's some kind of peak during the day. no matter what that average is, no matter what we've done to try and, maybe be more energy efficient, if we can't get that top number to come down, we've still got issues. So, and we've seen overall loads really level out, even though there's been growth in Huntsville over the last 10 years. Even with the recession, we still had some growth, some moderate growth in Huntsville. So with the growth of people and businesses coming in, loads have stayed fairly flat. So that's great. It shows that, that energy efficiency and new technology are making a difference in our loads. If you live here and you lived here last January, it got really, really cold. And when it gets really, really cold, we found that at some point there's a tipping point and you're going to go right back up there to the top of where you always were. So just supporting all that heating load was a huge burden on the system. And some of you, I'm sorry, probably felt that worse than others. So this is what we're dealing with, and that peak I think is around 7 megawatts, the average around 4 megawatts. But that's what we want to do, is try to flatten that out, and a lot of things are happening to try to do that. They may raise or lower different parts of those, but again, it's that peak that we really need to reduce. So what are we trying to do? What have we been doing, and what things have happened? We've talked some about energy efficiency and LED lights in our homes and LED lights for our street lights. We're doing some studies now on replacing street lighting with LED lights for energy efficiency there. If you have replaced any of your lights in your home, and I'm sure you all have, I changed out all the lights in my kitchen with new LED light fixtures, lowest wattage I could find. I can't turn on all the lights in the kitchen because it's just too bright. And so we found with some of our studies, we go into different neighborhoods on different streets and put up different types of lights, and we'd get some complaints about some of them. So like Dr. Ivester was talking about, some of those lights, the color of the light or the harshness of the light, we need to find the right light that's pleasing and comfortable and is not going to irritate or distract drivers. So there's a lot going on. It's not as simple as just buying an LED light. Then we've also got to think about, what do we do with all these lights we got up? A lot of them still have a lot of useful life. So what's the strategy for moving towards those replacements without basically wasting money? Something else that we're pretty proud of, and this is another project that we worked on in conjunction with TVA. Our customer service group won a grant for $12 million from TVA to do home energy makeovers. So 1,300, 1,400 homes in our service area were renovated to provide energy efficiency in terms of maybe installation, maybe new windows, maybe a new higher rated heating and cooling unit. So it's made a tremendous impact in Huntsville, and certainly to those 1,300, 1,400 people that we were able to affect. We are, as Jason mentioned, we're kind of the link. As an LPC, we're a link to those programs that TVA offers, the Energy Right programs, the Energy Partners programs, the Green Power programs. These all used to just be, about, if you remember the days of turning your water heater on and off. Maybe if you had a pool, you turned your pool on and off, or you might let us once turn your air conditioner off, but then you change your mind. But it used to be about that, and now it's getting more into, well, I want to do some solar panels, or I want to do something else. So the programs have really changed as this technology has gotten inexpensive enough that people are going to try it. So we're kind of that link as being the locals here to TVA and often facilitate those projects for them. We also, because we're not just an electric company, we're water and gas, our natural gas department is trying to grow and offering incentives and trying to make customers aware of the value of natural gas and the overall energy benefits of natural gas. So we want to be the energy company, not just the electric company. One other thing that we're looking at, well, actually we have launched our smart meter program, our AMI program. It's been, years in the making of setting up all the right computer software integrations and getting that all in place. But since towards the end of 2018, November, December, we've been installing, replacing meters with smart meters. This is scheduled to take about 3 years to do, but it'll provide our customers with much better information about their consumption habits and what's going on, and give them some hints over what can they do to actually reduce their consumption and be more efficient. And certainly our commercial and industrial customers have been wanting this information for a long time, because it can be very critical with the amounts of energy that they use to find ways to control that a little better. So we're pretty excited about that. I also mentioned dark fiber. So why fiber? Why would we bother with it? Well, one is, we put stuff on poles already, so we think we're pretty good at that. We also have lots of those substations and water tanks and even some gas facilities and our own campus and buildings, service centers that we've got around, where we need to connect and have that communication and have that data connectivity. We have radios that we communicate with to operate some of this equipment and get information back from this equipment. So we have our own needs for a very strong, reliable communication system. So we had been installing fiber for many years for our own use. That's recently expanded as we're trying to get to more and more of our area. We have dark fiber available for lease, and that's why I have had Google on the previous slide. Google is our anchor tenant, I guess you could say, as far as wanting to get out and lease our fiber to get to all of our consumers and provide them with internet services. So why is this good? It's great for business to have access to high-speed internet and broadband, and it's great for home businesses. There's a little clip of a Google map here. If you're looking at Google Maps now, you'll see these little businesses popped up all over the place in residential neighborhoods. People are working from home. They've got to be connected to be able to do that. Certainly, as I mentioned, our substations, our water tanks, this gives us much more, we have much better access to be able to operate our facilities better, and for the city to operate city services a lot better. So that's all I've got, and I'm going to pass it over to Dr. Rob Strait.
You can just go ahead and hit the next slide if you would.
Americans, ask not what your country can do for you, ask what you can do for your country. My fellow citizens of the world, ask not what America will do for you, but what together we can do for the freedom of man.
Walter Reed National Military Medical Center has one of the most advanced NICUs in the region. With over 80 highly trained staff members on call 24/7, we provide the highest level care to infants in the entire National Capital Region. With a 24-bed capacity, we care for neonates as young as 23 weeks, as well as term newborns requiring surgical procedures or intensive care. We employ the latest technologies available to ensure our patients are given the best possible care. The proximity of the Mother-Infant Care Center and the operating rooms supports ease of transport and movement of infant to the NICU if necessary. Our full-feature incubator and radiant warmer enable rapid stabilization with minimal interruption to maintain thermoregulation, which is critical for both premature and term infants. It also allows full access for procedures without need for movement of the infant. Some newborns may experience an interruption in the supply of oxygen and/or blood flow going to his or her brain and body. This kind of interruption can happen for a number of reasons. In order to reduce the risk of permanent damage, we can offer induced hypothermia with total body cooling to reduce the likelihood of any complications.
There's a good shot. Right. Good.
Okay, you can go to the next slide, please. Well, welcome to Energy Huntsville and our splashdown here. And the 50th anniversary of the Apollo program is an appropriate time for us to be here, I think, in Huntsville. And what I want to do here in the next couple of slides is just talk about some of the organizations that I have the privilege of working with. The first is Sane Engineering, my employer. As a matter of fact, Sane Engineering is responsible for some of the energy efficiency programs and making sure that energy is available at Walter Reed Medical Center. I personally worked on the hospital programs at Little Rock Air Force Base when I was resource efficiency manager there with Sane Engineering. Also, a very important aspect of what we do is bring our customers and the people who run the facilities and educate them in new types of technologies. So we had programs where we went to companies like Nordex and learned about wind turbine technology and the different ways of applying that. Some of the other activities we also support is over there we had a solar experimental station that was developed for local elementary and middle schools, so the students could start learning hands-on with solar panels. You can see it's on the ground, so they could actually go up there and touch it, and it's really powerful when you run your hand over a solar panel and you got a meter and an oscilloscope and you can see the power fluctuate and things like that. And we tied it into a weather station and some other activities. So that's one of the groups that I work with. Go please, next slide. Okay, USDA. I'm part of the USDA's what they call Earth Team. It's a volunteer organization. The USDA will be here tomorrow. They'll be talking about some of the rural development activities and their funding programs they have for help you in downtown Huntsville, but as soon as you get outside of the city limits, they have authority and they can help put in programs. Some of the projects I've worked on is out on the left is working in agricultural stations. The far left is we've doing resource monitoring of water quality and things like that. So we're using solar power to power these things, also to use that power to monitor agricultural pumps and other activities out in the field. In the center, standing next to a USDA RDA project out in Nevada, where we were actually making hydrogen using renewable energy to generate hydrogen through an electrolysis process. On the far right is some of my more recent activities where we've been doing energy audits and energy assessments so that farmers can get funding from the USDA to replace the old diesel pumps and irrigation pumps with modern electric pumps with VFD drive units in there. And also, how can we take that same technology and use it to benefit rural energy co-ops and that type of thing? There's a lot of other benefits that come out of that. Next slide, please. Okay, here is a nonprofit, it's Mara, and this group has done a lot of different activities, everything from working in the community sector on smaller scale energy initiatives, trying to train the young people, our next generation of energy engineers, and giving them hands-on experience, doing system engineering studies. And one of the things I'll talk about in a presentation tomorrow, later, I think it's tomorrow, is more how we need to look at energy as a system in a system engineering environment. And then on the right, working in renewable energies and also in things like aquaponics and how do we do farming using more renewable energy. So that's one of the programs they have. There's some posters out there on some of that activity. Next slide, please. Arkansas State University. Yes, I'm taking another PhD program. I'm not sure how I'm going to be able to keep doing that from Huntsville, but I'm currently still in there. And we bring in folks on the left. We have representatives from DOD out there talking about opportunities and what Arkansas can do for the Department of Defense. And then the center slide there, the individual speaking is Mr. Walter Ellis. Unfortunately, he couldn't make it here for this, but he was the one that wrote the programs and uploaded those programs on a regular basis for the Apollo shots to the moon. So it's really a pleasure to be able to work with him. Next slide, please. And then a new area that I've gotten into is with Homeland Security and the ICS CERT team, where we're the people that have to respond to all types of cyber attacks and security issues. I know we hear the word cyber quite a bit, but cyber is just one piece of information security. And we'll talk about that in some of my other presentations, but there's a whole other realm of security that's going on that we're involved with. And we do analysis of systems down there. I don't recall what company, it doesn't really matter, but it's a system that we found some faults with. So we go back to that company and we help them try to patch those errors and get that system so that it's safe for industry and government to use. And one of the cool things down here in the bottom is Homeland Security has a lot of agencies. One of them is FEMA that you all heard about. Well, this is what they call a multi-radio van. I was the design engineer on that quite a few years ago. But that we can communicate with any system anywhere around the world. And we actually have a desk in there for the President of the United States if he has to be in there. So those are the types of things. We also have training that we offer for people. But those are the types of things we do and the types of things I'm involved with. And all of this goes back to the community as we go on to discussions with PSC. So last slide, please. And it just goes into really what we're talking about as a community. This is for our Economic Development Committee here at Energy Huntsville, and some of the ideas that we have to help improve the economy locally using energy as a basis for that. And then the last slide. One more slide after that. That's just my team. And then here's a question I have for you. If you look at these families and their homes, and then you look at these logos, and I couldn't there's a lot of logos I just couldn't fit on there, a lot of good companies, so I don't want to leave anybody out on purpose. But what I want to ask you is, as we go through this and you hear the discussions, answer the question is, what do these logos and these households have to do? And we'll get into that as we get talking in the panel. So thank you very much for letting me be here. And I'd like to introduce Mr. John Maurer.
Keisha, will the clicker work? I'm not sure. You can give it a try. Okay. Let's see. Yeah. It's working. Okay, I'll flip my own slides. Hello, friends. I'd like to start with just a question. Hydrogen is sometimes called the energy of the heavens. If hydrogen is the energy of the heavens, then what does that make coal? I'm here to talk about hydrogen. Hydrogen just might be in your future. And I'd like to talk about that future, at least in the near term. And by near term, I mean the next 10 to 15 years. Siemens is a very long-term company. Siemens has been in business almost 170 years. And we tend to look at things over the long term. And our vision in the future out to Stardate 2050 is that energy system decarbonization is absolutely essential if we are to combat the effects of greenhouse gas emission and climate change. And so for Siemens, a total system solution is necessary in order to get to a low carbon future. And as part of that, we see the need for hydrogen fuels in gas turbines. And so why might you ask gas turbines? That's old technology. Well, in renewables, you can't tell the sun when to shine. You can't tell the wind when to blow. And as a consequence of that, there are many times when the weather changes and power generated by these non-dispatchable resources absolutely collapses. Well, the grid doesn't care. People are cooking, people are working. That demand for electricity could care less if the weather has just changed. And so we often see very large demands for electricity that come about very quickly in order to balance the load on the grid. And gas turbines have the capability of ramping up very rapidly and delivering sufficient energy to the grid to be able to balance that rapid swing in generation that frequently happens with renewable, non-dispatchable resources. Something very interesting happened last month. This is my colleague, Zhu Qi, who is the Siemens Energy Chief Technical Officer. And he was here in Brussels to sign a commitment letter with all of the gas turbine manufacturers that do business in Europe to make a commitment to hydrogen. And that included Siemens, General Electric, Mitsubishi, and Saldo, and several others. So literally everybody got together, thrashed out an agreement that we would commit to hydrogen for the future of gas turbines. And so, what is that commitment? What it means right now is to be able to burn 3 to 5% hydrogen, which is not too much. By 2020, to be able to burn 20% hydrogen. Now we're getting somewhere. And by 2030, to be able to burn 100% hydrogen in gas turbine power plants. And the basis for much of this for Siemens is R&D development under the Advanced Hydrogen Turbine Program, which ran for a number of years and concluded in 2015. So this includes a call to action for the gas turbine manufacturers and the European Union in general that gas turbines are required to balance renewables on the grid, that the world has not done very well in transitioning to a low-carbon future, and so greater speed is needed in that transition. It also calls for public and private investment, not just government resources, but corporate R&D resources, of which Siemens spends hundreds of millions of dollars a year on gas turbine research and development, and that there are no favored technologies, so we have a level playing field. But we have a huge installed base out there, and so what we develop also has to be retrofittable to the existing fleets, and that is, of course, a business opportunity, but you can't do one without the other. Things aren't all rosy, though. There are definitely some barriers to success here, and we've studied hydrogen turbine power plants for quite a number of years. And right now, the gas turbine can swallow more hydrogen than can easily be produced. This was a study that we did for the Japanese government just a couple of years ago. And they're looking at a hydrogen supply chain. But the key point here is that a large industrial gas turbine will consume tremendous quantities of fuel, 500 to 600 tons of hydrogen per day. And just to give you an idea of what that is, I'm sure you all saw the space shuttle out here, the Space Shuttle Pathfinder and the external tank. Imagine half a dozen of those external tanks drained dry every day, and that's what a single 500 megawatt gas turbine combined cycle power plant will consume. So the infrastructure is just not there right now. So our mission is 100% hydrogen, and what we've done is we've focused on the lower size, which is where the infrastructure can support the fuel needs. And so we're working on a demo plant. We're trying to get a program kicked off with the Department of Energy. And what we can do now is what you see here. We've been testing to 80 to 100% hydrogen content. We did this in the hydrogen turbine program. We got to 97%, but the difference here is this is dry, so it does not require steam or nitrogen. And so that's a step forward. It makes the plants much simpler. So we got to 80% last month. The next target is 100 within the next year or so. And we also have the capability in the smaller aeroderivative sizes to support this commitment. Thank you very much, everyone. Kareem, over to you.
Thank you, John. Appreciate it. Good morning, everyone. It's great to go last because you have all kinds of time, right? And Sean, you're not going to stop me at 10. You're not going to give me the flasher. You are. All right, how many folks from Alabama? Oh, cool. I got a little joke for you. How big a hole do you have to dig to bury a dead elephant? Nobody? How about 44 by 16? I guess there are no Bama fans in here. There are people from Alabama, but no Alabama fans, huh? All right. All kidding aside, I'm Kareem Manji. I'm with MCOM Sustainment Directorate. Ms. Keisha, I'm going to let you control my slides because I like to be a little, I kind of wanted to walk around, but I guess I'm being filmed, so I have to be stayed hooked on to this podium, okay? We thank Energy Huntsville for giving us an opportunity to present here today. This is an inside look, if you will. So far, we've heard from industry, we've heard from Huntsville Utilities, TVA. This is a little bit of an inside look at what happens at a garrison or installation level. So hopefully this will be good for you all, for industry, other federal agencies. I think there are some state agencies represented here. Next, please. So who are we? Who is MCOM? I'm sure some of you have probably heard of us. And it is changing right now. As of January 18th, it's a little bit of a different equation. There was a development where MCOM, which is a land holding command, kind of got bought up, if you will, by AMC, Army Materiel Command. And the details of all of that subordinate command merger is coming out. It's still yet to come out. Next, please. Oh, boy. So this is just a little org chart. I'm not going to go into too many details. Tells you how we're structured. MCOM developed 2 years ago, I believe, a little bit before 2 years, some directorate regionalization approach. There are 5 directorates that they formed. We, our sustainment directorate, we have a fleet of 17 installations that we support. The sustainment directorate that we're a part of, those are the installation and the major commands that are at each of those installations. Next, please. This is down at the sustainment level. You know, we have a SES director level that runs the sustainment directorate, and then all the positions under there. The one that's highlighted is Public Works, and those are the 17 installations that we support, and those are the ones that I'm going to present to you today on our initiatives for energy and water. And I like to use the word productivity, not resilience or conservation or anything like that. Yeah, that's recent. I think that was your question, right? Yeah, I think I'm tracking with your question. What's happening is, though these are the 17 that the Sustainment Directorate is directly responsible for supporting, AMC itself has 23 other installations that are considered specials. Ted, right? Is that your name? All right, sorry. Yeah, forgive me. Anyway, let's save the questions for later. Am I right, Sean? All right. All right, next slide, please. So what are we doing? These are our hot rocks. And I'm sure if you go to any directorate that is Installation Management Command or AMC or Army Reserve or National Guard, it's going to be probably the same, right? We got an op order that's coming out. Now, normally it should be out before 1 January. We're running tracking a little bit late on that. That will lay out all your goals that we are supposed to meet towards energy productivity. There is a new little addition in there on emergency backup generators, so that's the only change. That outboard is pretty consistent year to year, but this year, that will be one change. For FY20, you all kind of, I hope, have a feel for how this works in the DoD world for building projects, getting them, appropriations for them, and then the funding and all that. So that's what that is. We're working on FY20 projects, energy water conservation, that's EWCR. That's kind of a big thing for us where we're presenting projects that are life cycle costs justifiable, and we present them forward to our command, senior command, who then chops them a little bit, and then we get so much funding divvied out. Projects with payback of less than 10 years are really now also being considered as a viable option. Before it was, a little bit less of a payback period. Now it's all the way up to 10 years or less. Highly recommend building retuning. How many folks have heard of retuning? What does that entail? It's a big deal, right? Retuning, we have a success story that I'll show you a slide of later. Produced enough savings for us where it justified the cost in like 1 year. So that's great payback. Things get out of whack, right? You're operating a building, a facility, over years it gets out of tune. You got to kind of keep it in check, kind of like my body right now. My little neck is getting a little bit out of tune, and I'm going to have to do something about that. What about IEWP? How many folks have heard of that? All right, cool. So mostly resource efficiency manager types. Not much industry has heard of that. All right, so as of FY21, all of our installations that have been declared critical mission and critical functions have to have an installation energy water plan. It has to be in place for FY19. For us, for Sustainment Directorate, there are 5 installations that have to have that in place by end of FY19. For us, FY19 is 30 September. So that's in progress. We've already kicked off 4 of them. One's upcoming. And then the 2 and 3 are just our goals or schedule for the remainder of our installations. Some of our initiatives are REM acquisition. That's Resource Efficiency Manager acquisition. We're looking at ESPCs, UESC buy-downs. A lot of money has been invested over the last, there are some installations that have had a UESC, ESPC deployed now for 20, 25, 30 years. It's not a new thing. So those are kind of getting to end of life, but the new ones that have a 20, 30-year life cycle, we're looking at buying those down. Kind of like, when you first bought your house, I don't know about you all, when I first bought my house, it was 14, 15% interest rate in 1980. I'm aging myself now, carbon dating. Anyway, you want to pay that off. When the mortgage gets a little, interest rate gets a little lower, you want to pay it off or buy it down, right? Lots of people are doing that. That's kind of what that is, ESPC, UESC buy downs. Metering. I don't know if you all paid attention on Dr. Ivester's brief. Metering is a big deal, right? So we're going down full path, wide open on that. Demand reduction. Utilities know what that is. We help out the utility when they have a peak demand or peak, where we're about to blow the 7,500, I think it was, megawatts. Then they want you all to kind of help them out. Cut down your demand, reduce your demand a little bit. What does that help the utility with? You don't have to build a new plant. Does it cost a lot of money to build a new plant? Yes, it does. Is it an environmental nightmare? Yes, it is, to get it licensed. So anyway, it's kind of a win-win for both, the utility as well as for the installation, because when you reduce demand, you cut your costs, you get some money back. Mock billing. What is mock billing? Right now, we have a lot of Army tenants and customers that are not reimbursing us because Army customers is a non-reimbursable class. So we send them out a bill. Hey, look, if you were a paying customer, you would be paying us $1.5 million a year. and it kind of makes them stop in their track and think, right? So that's what that is. Energy policy, we're trying to get some teeth, into the enforcement of set points. There's an energy mandate out there that sets, hey, in wintertime you had to have a 68-degree set point on your T-stats and 78 in the summertime. Does every installation watch that and enforce that? No. So the policy will help us. Next, please. This is a quad chart. It really gives you a good idea on where we are. So situation, we're under extreme budget crises, right? We're asked to cut manpower costs to support our futures command. Resiliency, security, those are some of the initiatives. We got lots of cool installations that are doing cool things. APG's got almost an 8 megawatt CHP. Picatinny Arsenal has got a 2 megawatt cogen plant, and they've also applied for a ERSIP, NRC Energy Conservation Resiliency Investment Program funding. So those are just some of the things that we're doing. Next, please. I'm running out of time. I've been called. I've been summoned. All right, and these are pictures of some of our cool initiatives. Edgewood at Aberdeen Proving Ground has got a CHP. Look at that curve. I mean, it's almost half in kWh consumption and cost. That is just really cool. This is right here at Redstone. What's happening there? About a 10 megawatt solar plant, solar array, with one of that 10 battery capable, battery storage. Next, please. This is Redstone I told you about earlier, building retuning. EUI, significantly lower. It's great for about a $200K investment, paid off in 1 year. After that, it's money in the bank. Next, please. All right, that's it. I guess this is question and answer for the rest of the panel. Thank you.
All right, so Q&A. Any questions for the panelists? And if so, I'll pass the mic to you, and I'll ask the panelist that wants to take the question, since we only have one mic, to use the...
I was wondering if you have any metrics or benchmarking of the resiliency and reliability requirements.
Yeah, we're working on that. It's something that's still very much a work in progress. And one of the challenges is that the metrics really have to our experience, really have to be customized to the customer and the site. And so I would say we have a variety of them, and there isn't one perfect measure. And it really has to align with the mission and the nature of the location. Resiliency for a hospital is very different than, say, resiliency for an office park. And so we look at things like percent of load that's sustainable in a power outage from backup generators, and how long that's sustainable under fuel that's on site. But as I'm sure you can imagine, intensive care units in a hospital need different numbers than an office park.
Other questions?
Are you recommending retuning then as kind of an alternative to recommissioning, retro-commissioning, that would be a less costly way to approach it?
I guess that question is for MCOM Sustainment Directorate, right? Yes, it is. Retro commissioning, I mean, those are kind of related, but retuning is really a little bit more focused. you take, hey, I want to do controls, and that's all I want to go in there and recalibrate and get it back in the tolerances that it was supposed to be. So that's a good question. But it is a subset, if you will, of a full building commissioning or retro commissioning, because retro commissioning does entail a little bit bigger scope. Did that answer your question? 10-4. Any other questions for me while I'm up?
Yeah, relative to your director's comments, you had a building automation system.
Yeah, that's a great question as well. So you know, we have resilience and then we have sustainable, right? I kind of wanted to go into a little bit more detail on that quad chart, but I didn't get that time to do that. Building automation system is really kind of a focus where you're really contributing towards conservation as well as resilience, right? Lots of people are pumping in lots of money right now into metering. Don't get me wrong, metering is great to a certain extent. You want to meter your big hogs and your energy consumers that are maybe not quite efficient, not run quite well. You got to meter possibly your reimbursable customers because you have to do that. It's the best way instead of estimating it by square footage and type of use and all that. But building automation can really produce a lot of fruit for you. It can allow you to do a demand reduction load shed in instantaneous time. Metering doesn't do that. Yeah, it will give you some metrics of measuring. Okay, you know, you can't, you know, you've heard that thing, well, you can't monitor where you can't measure. That's great. But BAS, a fully automated control system, is really, that's robust, helps you do both sustainable resilience and across the entire spectrum. Answer your question?
Absolutely. We agree totally.
Any other questions for me? Sorry, energy panel, I don't mean to hog this up.
Todd Dermer, I'm with Red Horse. It's more of an observation. I worked on the net zero program for many years with the Army, and now we're into this resiliency thing, and I have a fear, this is my observation, my personal opinion, that we're going to end up putting generators, we're going to start looking like Afghanistan on all these installations. I'm encouraged by the hydrogen piece, because I think that's a game changer. So it's just an observation of mine. I'm not sure what direction we're going, but I'll leave it at that. Thanks.
Does anybody else on the energy panel want to address that? Let me do that. I don't want to be here. Yeah, thank you.
Okay, I work at headquarters AMC. Actually, we sit right next to each other, and he does IMCOM, and I do AMC bases. But I also have a great team working with me on this resiliency problem. We have folks from partners with DOE's National Energy Technology Lab, NETL, here from the University of North Dakota, who is working on a project with my energy manager from Red River Army Depot, Mr. Paul John over here, and we're looking at the resiliency issue. I also have the privilege of having the energy manager from Iowa Ammunition Plant. She recently retired, but we kicked off a resiliency project there. And I kind of want to spend a minute talking about what we found out. When we went in, the Army has a directive of 14 days resiliency. And when you go out to an installation, especially from a headquarters level, and you say 14 days, all you hear is all this pushback on why you don't need it, they've got this, they're not going to need it. And, you know, if you do it 23 times or 17 times, it kind of gets to be a little bit humorous on our end because we've heard it all before. But for those folks out in the field, it may be their first time they're addressing this. So it's real for them, and we have to take that into consideration. We are looking at, Linda helped me put together a project to do what we call coal gasification with the DOE working with us on that, where we're going, coal gasification is a clean way of using coal. We don't burn the coal and put smoke in the atmosphere. We actually gasify it. We capture everything. All the products are captured and reused, and plus we're making energy at the same time. So we had a working group put together with folks from Sandia Laboratories. We had the Navy, Naval Surface Warfare System out there. We had DOE out there. And we had the Army folks there, and we started around the table, and as people went around the table, they started talking about what their critical mission is. And we could find the same thing, whether we're in a hospital environment, a manufacturing environment, in your own home. I mean, a critical mission. Don't let the freezer thaw out and you lose $500 worth of meat, right? As it turned out, what came out of that from everybody, you know, coming in there, how are we going to do 14 days? The unanimous agreement of the working group was, at Iowa Ammunition Plant, we have critical missions that need to run 24/7, 365. So resiliency, like somebody mentioned a little bit earlier, is based on different organizations, but you have to do the systems engineering analysis. The days of us coming in with, you know, the low-hanging fruit, we can change some light bulbs and just ad hoc energy measures are over. We're now in a phase of energy management where we have to apply hard systems engineering methodologies, and that's what we started doing out there, and that program is continuing on. And we have another gasification to do the same thing. We're looking at how do we use gasification for resiliency out at Red River. Yeah, go ahead. Right. That is a big issue. We're facing that at across our installations, and with AMC, I think you are too. And did you want to jump in there, or? All right. So one of the areas that we're looking at, again, you know, one of the things I'm doing is doing advanced technologies and new technologies. Is, you know, how else can we collect that data? How else can we do those controls? And one of the systems that's been out there for a long time, I work with this with the USDA as well, is what we call power line carrier. It's the ability to communicate over the same electric line that is carrying the electricity to the device. And it's broadband, so it's not, you know, some people may have heard about it years ago, 20 or 30 years ago, when it was infant and it didn't work very well, but now it's full broadband capability. Why is that important for control systems? You don't have to run any fiber optic. You don't have to link into a secure network. If you plug into the outlet, you're connected. And what is also powerful about this technology is, from the cyber standpoint, is that we can do things there that we normally can't do with a straight internet connection. We can do frequency hopping. In other words, we can hop all over a given spectrum of frequencies at a random cycle, so that you'd have to know where we were to even intercept that. We have encryption technologies, so we can combine these different types of technologies to make a secure system. So we're investigating how do we deploy that. When we look at, I work with some of the folks that are here from some of the different companies that do meters, and we're looking at that type of technology within their systems, because this technology is embedded in almost all of our meter systems and control systems. A lot of them already have this technology in it. So I hope that helps. And I'm not by myself. I also want to say, I got Jim Hudlow here, who sits next to me on the other side. He's a REM. And I don't know all of the new REMs from Red Horse that are working with us, but I've been trying to say hi to y'all. And so we've got a big team of folks out here. I think there's, what is there, 6, 8 of us now total within AMC. We're all addressing this issue. And if you want to talk to any of us about how we're doing that within the Army, we can share that and see how it would play into industry.
So we started a few minutes late. We're going to go ahead and end things, but feel free to ambush the panelists in the hallway.
I gotta take us to what, I gotta answer the question that nobody asked me yet, because I asked them to ask the question, if they have a second. Could you put up the slide real quick? I think everybody would like to see this. Go to my next presentation. I brought it up here just in case we couldn't get it up in time. But we were talking about productivity a little earlier. And when we talk about energy efficiency, and I had a great opening act over here. I already thanked them. I said, you couldn't have done this. Because the biggest thing is, you know, it doesn't come from the government about energy productivity, but the DOE is leading the way in what they call the Accelerated Energy Productivity 2030 program, and it's talking about productivity. So the question was about what happens, what's the relationship here. The relationship is this. if we were to go out and do an energy efficiency program, and I pulled some numbers, this would be on the internet later, but I took the numbers off the internet, and we have approximately, I have to find my numbers here on the other page, I'm sorry. How many households we have here? Yeah, I didn't get that page printed, I apologize. But we have about 500,000 people in the Huntsville region. With that, we have about 250,000 homes. If we did an energy efficiency program, if we took the technology from industry and government and brought it down to the residential level, and we just saved each one of those homes $100 a month, that's $25 million a month that is now going to be spent. And where is that money going to be spent? Toyota, Jack's, Pepsi, McDonald's, you name it. Those people are going to spend that money. But that's just a small piece of the pie. When we put these energy efficiency productivity measures in, what we're looking at is how well does industry perform. And when we start looking at what the total value of these are, I didn't catch all of the value. We're talking if we were to invest $680 million into energy efficiency upgrades, the insulation programs like you were talking about, the value every year is over $1 billion to this region and savings. And those savings come from people not being sick to go to work because their homes are well, their children are in well-insulated homes that are warm, and they're not skipping, not having to miss school, and then people have to skip work because they have to stay home with their kids. Performance, I have a whole presentation on these issues, but we're only scratching the surface when we say we're going to save $10,000 at your factory by changing the lights. What about the productivity measures when we put in better lighting and we're doubling the production, or we're adding 20% or 10% to production? You got $1 billion factory, a year factory, and you just added 10% to your production. That's the money that we need to be looking at, because that's the money that comes back into our economy locally and helps everybody all around the thing. So that was to kind of answer that question that I put up there. Thank you for taking the time.
Thank you, Sean. Thank you, panel. It's time now to go and network and eat lunch. They say it's on the people from Huntsville, but it's somewhere. Thank you very much.